Now we'll go with 4 problems. These 4 problems are very important regarding the infinite rigid walls. Okay, the particle inside the wall confined in the wall, and both the walls will be rigid walls which are infinite. Considering an infinite wall well width, so well width is given as 1 angstrom. Calculate the separation between the two lowest energy levels. So we'll have to find out E1 and E2. The first lowest level will be E1, second lowest level will be E2. So we are going to find out the difference between these two. Separation between the lowest energy levels. And second one is the frequency and wavelength of the photon corresponding to a transition between these two levels. So we are going to find out the frequency and wavelength. Okay, let us see how it goes. En equals n squared h squared by 8ms squared. So this is the expression we know already. And you substitute all the constants here. L is given as 1 angstrom. So L will be 10 power minus 10. Okay, 1 angstrom will be 10 power minus 10 meters. So 10 power minus 10 whole square. And M will be 9.10 power minus 31. Your h squared will be 6.6 10 power minus 34 whole square. And n squared. N squared you can find out. Okay, we will stop for the time being. So you just calculate the remaining term, that will give you 6.038 into 10 power minus 18 n squared in terms of joules. I am going to convert joules into electron volt. So dividing by 1.6 10 power minus 19, that will be converted in terms of electron volt with n squared. Okay, now 37.73 n squared electron volt. So it will be always in terms of 10s, 20s, 40s, 30s, 100 electron volt. Okay, it will be value will be something like this. So you have En equal to this much n square. What is asked? The separation between two lowest energy levels is asked. Okay, so now E1 equals 31.73, the first one. So 1 square multiplied by 1 multiplied by 2 square will give you E2. So this is your first two lowest energy levels. You just subtract, that will give you the separation between these two energy levels. E2 minus E1. So E2 minus E1 will be 113.19 electron volt. Is it clear? Okay, now you just convert this one into joules. So multiplied by 1.6 10 power minus 19, that will give you 1.8114 into 10 power minus 17 joules. Okay, so the first one is over. The second one is the frequency and wavelength of the photon corresponding to a transition between these two levels. We are going to find out. Of course, we will have to use Bohr's postulate. So this will be your Bohr's postulate. Okay, 1911. So nu equals E2 minus E1 divided by h. E2 minus E1 just now we have found out, which is nothing but previous one. So we have found out, just now we have found out. So 1.8114 10 power minus 17 divided by your value of h will be this one. So dividing, that will give you nu, which is equal to 2.73 10 power 16 hertz or 1 by second. Okay, is it okay? So it will be around always 10 power 15, 10 power 16, 10 power 17. Okay, don't forget. So within this range only it will lie. Now lambda equal to, because what is asked? Frequency and wavelength is asked. So we have found out frequency. So lambda equal to c by nu. So substitute the values for c and nu, which we have found out now. So it comes around 110 angstrom. So 1.1 10 power minus 13 comes around 110 angstrom. So now we know already 4000 to 7000 angstrom will be your visible region. So the values which are very lower than that of UV, that will give you ultraviolet region. So 110 angstrom will be in the ultraviolet region. So the answer is what is asked? The wavelength of the photon corresponding with the transition between these two levels exists only in the UV region. Is it okay? First problem, very simple problem. We have used the expression for energy. Okay, and second problem. Now we are going to use the expression for wave function. Okay, calculate the expression value, the component of px of the momentum that moves only in the x direction. Px of the momentum of a particle trapped in one-dimensional box. So we are going to find out the expression value of px. Okay, we know already psi n equals root of 2 by l sin n pi x by l. We know already. What is the expression for expression value? Px equals px sandwiched between your psi star and psi with the integration. Minus into plus infinity we know already. Now px, the expression for px in the terms of operator will be minus I h cross partial d by dx. You substitute in this. So we have psi star minus I h cross partial d by dx psi. So P sandwiched between psi star and psi. Here you have root 2 by L. Here also we have root 2 by L. You pull it out, that will give you 2 pi L. Okay, minus I h cross I have pulled out. So remaining term I have written as sin n pi x by L cos n pi x by L. Now this 2 sin theta cos theta will be sin 2 theta. Correct? 2 sin theta cos theta will be sin 2 theta. Okay, not sin theta by 2, it is sin 2 theta. That's a mistake here. 2 sin theta cos theta will be sin 2 theta. That's all. So that's a mistake here. So you have minus I h cross. Already we have pulled these 2 out. So we have n pi divided by L square sin 2 n pi x by L. It is not that expression. Okay. 2 sin theta cos theta will be sin 2 theta. Is it okay? Now we are going to integrate. Sin 2 n pi x by L we are going to integrate. So which goes like this. When you integrate, that will give you minus cos 2 n pi x by L divided by 2 n pi by L. So to remove this minus sign, I have changed the limits. Okay, I have changed the limits. So 0 on L. Okay, you now substitute cos 0 is 1. So we have written 1 here. And you substitute L and L will get cancelled. You have cos 2 n pi. So it will be cos pi is minus 1. Cos 2 pi, cos 2 n pi. Cos pi, cos 2 pi, cos 3 pi, 1. So 1 minus 1. Okay, cos 0 is 1. Cos pi also will be 1. Cos 2 pi also will be 1. So you have 1 minus 1 which is equal to 0. So this wave function we have found out, substitute the wave function, and we have found out the momentum. Momentum becomes 0 here. Very, very important conclusion. I will say within a minute. Okay, the expression value of the momentum of the particle is 0. Very, very important result. You just remember this one. Okay, the expression value of the momentum of the particle is 0. You just remember this one. Okay, it's very important result. We are going to apply this result in the next problem. Okay, you remember that answer. Find the expression value of the position of the particle trapped in the one-dimensional box. So now you are going to find out the expression value of x. Earlier we have found out the expression value of the momentum. So now x. The same procedure. Psi star x psi dx with the integration minus into plus infinity. Okay, your psi will be this one. Expression for psi will be given as given. So you have x sin into sin, that will give you sin squared n pi x by L dx. Okay, and of course sin squared theta will be 1 minus cos 2 theta by 2. So you will have x, instead of this I can substitute 1 minus cos 2 theta divided by 2. These 2 and that 2 will get cancelled. So you have 1 by L. Is it okay? These 2 and these 2 exist, so that 2 will get cancelled. You have 1 minus cos 2 n pi x by L dx. You just separate these two terms. This term here and this term here. Okay, so you have now 1 by L x dx integration minus, you have minus 1 by L x cos 2 n pi x by L dx. Okay, now we can solve this integration using udv method. udv equals uv minus vd. So as usual you will have to keep this as u, and this is nothing but dv. See, this nothing but dv. So you will get cos in terms of sine. You will get cos. So because in terms of sine, so we will be in terms of sine. Now you substitute the lower limit and upper limit for uv. U will exist, of course. Okay, u is there as x. Your v will be in terms of sine. You just substitute the limit 0 on L. This will become 0. This will become 0. Sin 0 is 0. You have sin 2 pi, 2 n pi divided by L will be there. Okay, this substitute L will cancel. So sin 2 n pi, sin 2 pi, 0. So you need not calculate anything. You just imagine and you can say that this becomes 0. Is it clear? So now the answer you will get as, you substitute for L, so you will have, this becomes x squared by 2. So this becomes L squared by 2, 1 by L. L will cancel. You will have the average value is L/2. Okay, the average position of the particle is at the middle of the box for the ground state. Is it correct? For the middle of the box. For the middle of the box. So L/2, the average value, the mean value of the position exactly lies exactly at the middle of the box. Correct? What is the momentum value? 0, which we calculated from problem 2. Correct? So what does it mean? One side we have calculated L/2. The particle exists exactly somewhere here, the mean position. The another side we have calculated the momentum which is equal to 0. What does it imply? Uncertainty relation. It's very clear that when you are going to get the answer for momentum, you will never get the answer for the position. When you are going to get the value for the position, you will never get the value for the momentum. It's very clear. See? Because at this point momentum is 0. Particle exists. We can find out the position of the particle somewhere here. The mean position of the particle will be at which lies at L/2. Momentum is 0. So it clearly proves that uncertainty principle exists. Okay? Very important conclusion. Then last problem, problem number 4. Verify the orthogonal property. Orthogonal property, we know already, psi n of x which is equal to 0. Integration. Orthogonal property. Which is equal to 1 is normalized. These two conditions are very, very important. So verify the orthogonal property of the wave function of a particle in one-dimensional box. And of course we know the wave function. Your psi n of x dx which is equal to 0 when n is not equal to m. When n equals m, it becomes 1, normalized. You substitute for psi n of x and psi m of x. You will have these two expressions, correct? And of course, the formula goes like this. 2 sin x sin y will be cos, suppose you have sin a, this is sin b, we will consider. So 2 sin a sin b will be cos a minus b minus cos a plus b. No simple formula. Now you are going to integrate. When you are going to integrate, you will get only sine term. Here also you will get sine term. You substitute the lower limit, sine 0. You substitute upper limit, that also will become 0. Just now we have seen this one. Okay, in both the conditions this will become 0 because this will become sin n pi. So sin pi is 0, sin 2 pi is 0, so sin 0 also 0. So you will get this expression as 0. So hence it is verified that we will get the answer as 0. So both the wave functions are orthogonal to each other. Okay, so usually ground state and excited state wave functions will be always orthogonal. That's very important conclusion. Okay, so we will stop up to this. These problems are very important problems for CSIR examinations. Okay, so thank you students once again. We will see.